Hey pre-calc friends, in this video I just want to present you with a couple more problems to close out section 3.4. So we're really good right now at solving log equations and solving basic exponential equations, but how can we use them in real life? And one of the best ways to play with math in real life is with money. So this video will teach you a little bit about how we can make money and how long it takes to make money, and plus a couple of additional miscellaneous problems from section 3.4. All right, so let's put some money in the bank and see how long it takes to grow. So that's going to take us back to our compound interest equation, if you remember. P of t equals P sub 0, 1 plus the rate over the times compounding raised to the nt. And again, P sub 0 was your starting amount. P sub t was your ending amount. And then we had other things like the rate was the interest rate, and we always put that as a decimal. And then the n was, again, how fast it was compounding, whether it was monthly or annually or quarterly and such and such. Okay, now here's the way it's going to be asked. I'm going to tell you, we're going to start with a certain amount of money. I'm going to tell you how much I want to make. Your job is to figure out how long is it going to take to get there. So you're going to need to solve for the time t. And look and see where it is. It's in the exponent, which means we're going to be trying to solve an exponential function, just like before. And like we were doing before in our mobile notes, doing this using the ln function. Okay, let's get a good starting amount. Let's say you're starting with $100. And I want to know how fast will $100 get to $1,000 if I say our rate is 6.25%, and we're going to compound, let's say monthly. Okay, your job is to figure out what's t. How long will it take? What would time be equal to? So why don't we plug everything we know into there and see how we can solve for t time. All right, so our new equation, bring them on down here, would be, now the final amount, P of t, would be the 1,000. That's what I want to get out. Equals, the starting amount was the 100 that I began with, and we have 1 plus, the interest rate was 6.25%, but remember we're going to write that as a decimal, as 0.0625, good memory, and we're compounding monthly. Remember, monthly would be an n value of 12. And then up here in exponent, I'm going to raise that to the same n value of 12 times t. And t I'm going to leave there in red on purpose so that we can try to solve for that. All right. Well, this is actually exponential form. It might be hard to see that, but this is exponential form mainly because you notice if you look around here, there's no logs. There's no ln or even just the word log, so we're definitely in exponential form. So we're going to need to apply ln's in a second to try to free that exponent t. But before we do that, maybe it's a good question to see, what is my base? What is the number that I'm raising to a power here? Can you see? It's pretty messy. But if you notice, the one thing that's being raised to a power is this huge parenthesis here. And in compound interest, this is always your base, because this is the big number that you're always raising to a power. So the 1 plus r over n is always your base. Now, to make this a little bit easier to look at, friends, what if we rewrote the base so that it wasn't so messy like that? Can we let the base be substituted as, I don't know, maybe just a big variable x? And here's what I mean. That would turn our equation into this. 1,000 is my final amount. I start with 100. Times, now I change the whole blue rectangle, the base, as an x, a big X, being raised to the 12t. Now doesn't it look a lot easier and a lot prettier to look at? Don't forget though that x is the base and it is a number. Like this isn't another variable. I just put the x there so visually it's a little bit easier to look at. And we're just going to throw that into the calculator anyway. But your job is now, folks, can we try to get t free and use ln's? But before we do that, is there anything on this right-hand side that's messing up my base? Or, you know, is my base all by himself? I don't think he's alone yet. Do you notice other things that are on that side that's messing him up? I think it's this friend. So I think before we even try to apply ln's here, we need the base by itself. And to do that, why don't we move this over to the left side? But what's it doing? Oh, it looks like it's multiplying. So I think the best way to get rid of the 100 is why don't we divide both sides? Okay, that would give me 1,000 over 100 equals my base that I was trying to solve for, 12t is my exponent. Okay, so I was trying to get x by itself, and it's great now. 1,000 over 100 just becomes 10. So I'm left with, let me just switch things around. Let me put the x on the left side like we're normally used to seeing. X to the 12t equals 10. All right, now we just got a normal exponential function like we've been doing, folks. Now we're good to go. Now the base is all alone. So bring in the ln's. Bring in the ln's. Here we go. We're going to take the natural log of both sides like we were doing in the homework. This becomes the natural log of that big number base to the 12t. And on the right-hand side, I also have the ln of 10. Great. Okay, remember, the whole reason we're doing this, friends, is because I want to move this exponent free. I want the variable to be outside the log so it can be free on the ground and I can solve for it. So now that we're in log land, I can use the log law, which says put the power in front. And that's what I'm going to do. Put the power, the exponent, in front of the log. And that's great. Good. Yay, the t is pretty much free. So now what we need to do is just try to get the t by itself. And do you notice that's just being multiplied by all these friends here? So we just need to peel off those layers and try to get the t by itself. What I would suggest is, let's try to get this out of the way first. So why don't we divide this on both sides? And then when we're done with that, we'll divide both sides by the 12. So one thing at a time. How about we do 12t equals, and we'll do the ln of 10 and divide by the ln of that big base number that we had, 1 plus r over n. Okay, we'll put that in the calculator in a second, and then your final step is, to get the t by itself, is just divide both sides by 12. So I'll do ln of 10, I'll divide by the ln of that big base, and I'll take that answer, and I'll divide by 12, and I should be good to go. But just visually, to make sure we know what we're doing, remember the x was the whole 1 plus 0.0625 divided by 12. And you're going to divide that answer by 12. So I think what I would do is, I would try to put this whole numerator in first, and then divide by this whole denominator, but don't be afraid to use a lot of extra parentheses, and then hit enter. And then you're all done, go ahead and just divide by your answer, make sure your answer divided by 12, and we'll see what we get. All right, I'll give you a second to put that in the calculator yourself, and we'll match up our answers and see how we do. Okay, just to make sure you're on the right track, I put this much into the calculator before I divided by 12, and I got about 443.25 or so. Okay, so the math is not necessarily hard, sometimes it's just the calculator entry. So just the top divided by the bottom, I got about 443.25. Then I'm going to take my answer and divide by 12. Folks, if I start with $100 and I want to get $1,000 out, how long is it going to take with that interest rate and that monthly compounding? It looks like it's going to take about 36.94 years. Woo. That took a long time, but again, you went from 100 all the way to 1,000. Our interest rate was kind of medium low, but I think because we started with such a low amount of only $100, that's why it took so long. But that's how you're going to make money equations work. That's how you can solve for time. So just to review, back up what we did up here, friends. Given all this starting information, you plug everything into your compound interest formula. And then, this was just optional, but if it works for you, because this is just so dirty looking, is just to replace this huge parenthesis base with just an x. It made everything look a little bit easier. So once we did that, we got this equation over here. with x. Now x is our base, and we need to isolate x and get it by himself. And we did that by dividing the initial amount, the deposit money, onto both sides, dividing. And then we were pretty much good to go. And once we were good to go, that's when we brought in the ln's on both sides, and we solved just like we did in the homework before. So now, folks, you can start with any starting amount, figure out how much do you want to eventually make, and you can automatically find out, using cool math, how long it's going to take. So there's that kind of problem. The other kind that we have is a little bit more algebraic here, and it takes you back to Algebra 2. So write this one down in your notes. In this one, we're going to try to solve again for x, but now you can see that you see the word log. We are literally in log form right now, which means I'm thinking in order to solve, once you're in log form, I think I'm going to have to flip over to exponential form in just a sec. But before we do that, we can't do that unless we have one single log on one side. Once I get one log on one side, I can totally do the arrows and trip them and flip them over to exponentials. I just can't do it yet. Well, let's see. Look what I have on the right-hand side, just looking at these two pieces. Do you notice I have two logs being added? Ooh, do you remember your log law? Two logs being added. Go backwards, and they smush into one log of what operation? Do you remember? Oh, here we go. It turns into multiplication, right? So two logs added smush into one log of multiplication. Look at that. So those two logs are going to smush together like that into one single log of multiplication. The right-hand side I still have equals 3. Good. That's great, because remember up here what we needed? We need one log on one side. And yay, we did it. Before we didn't, because we had two logs up here, so we couldn't do it. But once we smushed them together, now we've got one log on one side. Okay, I think we're ready for exponential. Are you ready? Let's do the arrows. Here we go. We start at the base. 2 raised to the outside number, 3, is going to be equal to everything that's inside my log. Now that's a mess, but that's what it's going to be equal to on the right side. Ready? Let's write that down. Base raised to the outside number equals everything that was inside the log. Oh great, look, the logs are done. Yay, logs are gone. We're in exponential form. That's great. Not only that, but the x's are free. So why don't we just simplify this a little bit. 2 cubed, sure. How about distributing x squared minus 2x? Okay. This takes you back to Algebra 2 days, folks. Remember, when you have this type, this is our quadratic friend. So we have to set it equal to 0 and factor, 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 factor. Ready? Okay. Best way to get the 0 on one side is probably just subtract 8. Great. And he does factor beautifully. Check this out. X minus 4, x plus 2, I think, works. Great. Okay, that means from here, x is equal to positive 4. And from here, x is equal to negative 2. Good. All right, so far so good. We're not done, but we're like 98% there. So making sure you're good to go. Again, review what we did. We combined our two logs together, smushed them together. Addition went back into a product, multiplication. Once we did that, we were able to flip into exponential form. And then it's just been algebra. Now, here's the deal. Here's why we have to be really careful. I'm going to put a big star in this step because we have to stop and check our solutions. We only have to check our solutions when we're in log equations. Because, remember, what can we never ever take the log of? Do you remember what kind of numbers are bad? Yeah, negatives are bad, and the log of 0 is bad. We just can't do that. So we have to make sure when we plug our solutions back in, are we getting only positive numbers inside our logs? So last step on these problems, guys, is always plug it back in to make sure you're getting positive logs. Ready? Let's do it. Let's plug in the first one of 4. Okay, if I go back. Now when I plug it in, I have to go back to the original, way up here, folks. Not down here and not down here. Go all the way back to the OG and plug it in step 1. Now if I plug 4 in, I'm going to plug 4 in for x here. That looks okay. That's log base 2 of 4. That's positive. If I plug 4 over here for the other x, that's going to be 4 minus 2. That's also positive, so I think we're good. Yeah, all right. So I am a believer that x equals 4 is beautiful. That's an answer. How about negative 2? Okay, let's plug negative 2 in. And when I plug negative 2 into each x's, are we okay? Let's check. Okay, if I plug negative 2 in for x, ooh, that means we just plugged a negative inside a log. That's the log of a negative number. That's bad. How about over here? You plug negative 2 in there, and you're going to subtract another negative 2? Oh my gosh, that's even more bad. That's really bad. You're taking the log of negative numbers. So even though your algebra was beautiful, you did a great job, when you go back and double check, this answer doesn't work. If you remember from your Algebra 2 days, we call this extraneous. It means you found the correct solutions, but when you plugged them in, one of them just happens to not work. But your math was amazing. So our only answer here, friends, is x equals 4. So another big star here, folks. On these log equations, always plug it back in to double check. Okay, can you just start this one with me? This one doesn't solve very nicely, but I just want you to see the first couple of steps to make sure you feel comfy with this kind of log equation. Okay, we want to solve this log equation for x. So I recognize I'm in log form, and I eventually want to flip it into exponential form using my arrows, but I can't yet because how many logs do I have? I have 2. In fact, I have 2 logs being added. So, all right, there's my little clue for you. Can you pause the video for a second and see if you can simplify the left side first before we jump into exponential form? All right, 2 logs being added. Smoosh into 1 log of multiplication. And we still have the equals 5 on that side. So 2 logs being added, smush into 1 single log of multiplication. Great. Okay, we've got 1 log on the left side. We're good to go. Shall we do exponential form? Here we go. Can you see it? Okay, this would be 2 to the 5th equals everything that was inside of my log. There we go. That's exponential form. The logs are gone, and we would just do algebra to solve. But I want to stop right here just because it's not very nice solving-wise. We'd actually have to use the quadratic formula. Oh, do you remember? And we won't do those kind of problems that often in class. So I just wanted to see you set it up and then walk away. But there you go, folks. So we learned how to time money. Once you have a starting amount and you know how much you want to make, how long is it going to take? And then you learn some of these special log equations where you have to do a little bit of log law followed by a little bit of algebra too, friends. All right, great job on that, and we'll see you next time.